question, have a diagram. Okay, now we have a ball is released from the surface of the earth. Let me construct a okay, there's a tunnel. Here in the diagram, I'm showing big tunnel. So some part of the mass you removed. So tunnel, it is assumed that it will be very small, but the diagram I'm showing it big. Okay, there's a radius r. This much is there. Same diagram, I'll put it here now. Okay, let for our understanding. So let this be the mass of this planet or Earth. Let it be capital M. This is a tunnel. So here a particle is taken. It's released. The particle is released. It's released from rest. It goes and collides at the center. Quotient and between surface and ball, then distance traveled by the ball before second collision at the center. What to do? No, I think little bit some collision he has brought. So first, what happened? The particle, when it reaches center, what will be the speed? Will calculate. Any from that will get some help. That's all, no? When particle reaches the center, we'll see what any help will get it. I think I need one more diagram. I'll put all the diagrams here. Keep it here. So particle will come and collide here, no? Okay, I'll shade this particle. So when it comes and collides, here it will have a speed, say v1. Small letters I'm using, and it will immediately what happen will rebound with a speed v2. Okay, got this. And this is a tunnel. Somebody is asking, sir, where is the tunnel? This is a tunnel. How to calculate that v1? It is released from rest. So the best thing again, conservation of mechanical energy. Nothing to do. I think problem is over. Or the potential at the center, you know it. So I'll directly write the formula. So potential on the surface, m naught into v. There's interaction potential. I release from rest. 0. Potential at the center, Vc. I'm writing Vc. Vc plus it will have kinetic energy v1 square. So let's write potential on the surface minus g m by r. M naught potential on the surface will be 1.5 times that on the surface, or 1.5 m g. You write it. So this is v1. That m naught gets eliminated. So minus 3 by 2 if it comes on there, plus 3 by 2. Then solving, I'll get expression for v1 as gm by r, root of gm by r. It will rebound with a speed. The earth will not move, no? Am I right? Earth will not move. Earth will be fixed here. So what is the rebound speed? The rebound speed should be equal to E into V1. What is E? 0.5 V1. 0.2. 0 point. So 0.2 root of gm by r. What will happen to because of this speed? Because of the speed, it will start moving up. Then can it come out of the earth, or can it reach again the initial point? I think this is what a student has to. What can happen? Oh. Anybody? What can happen to the particle? There's a particle. Can it come somewhere here outside? No. E is what? V2 is less than, say, release from rest. It has reached its center with a speed v1. It has lost some kinetic energy. It cannot reach the initial point. Somewhere here, it will come to instantaneous rest. And again, it will go back. Again, I'll call this point as P. Now, how to calculate that height? For that, what happened? We should know at what height, no? So let this distance h or r, anything you can write it. Huh? No. Okay, shall we apply again from C to point P? The conservation of mechanical energy. And at point P, what happens? It will come to instantaneous rest here. And we know speed at point 2. So writing that m naught into potential at C plus m naught v2 square by 2 should be equal to m naught into potential at point P. Capital letters, small letters are very important. So we know potential at point C. Potential at point C will be minus 1.5 times of Gm by R. V2 is how much? 0.2 times of Gm by R is equal to m naught. What is potential at point P? Go back to the formula. Gm by 2R cube H square minus 3R square. From where this formula has come? Potential inside the solid sphere. That small r is what? H. Okay, let me take out this y again. So what we have to do? Everything we have to calculate the h. There is only unknown thing. G m naught, G m naught by r will get eliminated. Will I agree, all of you? See this? The term. So this will become minus 3 by 2.
Sir, 2h square minus 3r square, no sir?
2 is missing. Okay, this one, or 3 by 2 there. No, r square will be there. It should be this much only.
Sir, there should be a 2, sir, in denominator for
Denominator.
kinetic energy.
See the formula? Okay. We derive now this formula. Okay, ma? Huh?
Sir, for kinetic energy, sir.
Kinetic energy that one here. So 2 should not be there. Where I am? Okay, this one, yeah. Year 1, 2, no?
Yes, sir.
Yeah. So minus 3 by 2. 3 by 2 r. Okay, let me keep it r, no problem. Then this will be 0.1 by r plus this should be equal to 1 by 1 r will go, no? So 2r square, 3r square.
Sir, 0.2 whole square, no sir?
0.2 whole square. 0.01 or 1 by 10 r, anything it will be.
So 0.02 by r.
0.04, 0.02. Okay, this one here. Square is there, no? Anybody value h?
Sir, it will be 2r cubed.
2r cube. Okay, r we didn't cancel, no? R in LHS r in the numerator, r cube, GMM not. Okay. Anybody value of h? H equal to, okay, some answer I got it. 0.2 r. Okay, r by 5. Yeah, fine. Okay, that's good. H equal to r by 5, 0.2. What is the total? Let's go back to our question. What is our question? Total distance traveled before second collision. Distance traveled by the ball before second collision at the center. So first, how much of distance it will move? It will move r. Then what happened? It will move r. Then h. Then h. So what is the total distance moved? It should be r plus 2h. R plus 2r by 5. 7r by 5. So like this, some small collision ideas. Huh? Just only after collision, what is the rebound speed? That's all finished. Rest of everything is again, you have to bring the basic ideas, conservation of mechanical engine. I'll scroll down. Now, escape velocity is something we say, no, let's make it generalized here. Huh? Let's make it more generalized. Huh? Make it more generalized means, so I do have